In class 3 of week 4, we're going to look at a situation where we have a system of equations. As far as this course is concerned, we're just going to look at two equations, looking at solving two equations. If we look at these three equations, 2x equals 14, that has a unique solution. But x plus 3y equals 14 doesn't have a unique solution, because if you choose a value for x, then y can be whatever it needs to be to make the sentence true. So that doesn't have a unique solution. Similarly, 2x minus 3y doesn't have a unique solution. If you choose a value for x, then y is what it needs to be to make this sentence true. However, we can solve two equations in two unknowns together, and that will give us a unique solution. So let's do it by elimination. And in order to do that, we need to set it out in a particular way. Let's call that equation 1 and call that equation 2. So if we happen to add equation 1 to equation 2, what happens? We're going to get x plus 2x, which is 3x. 3y plus negative 3y is no y. And it leaves us with 14 plus negative 8, which is 6. Then, using our normal methods, we can say that x is equal to 2. Once we've got that x is equal to 2, then we can find, by substituting it into either of the equations, it doesn't matter, maybe into number 1. So then we've got 2 plus 3y equals 14. So 3y equals 12. So y is equal to 4. Now, we need to check that solution, because if we've done it right, those two values should make both of those statements true at the same time. So let's check. Let's check in the other one. So in 2, then if we say that 2 times 2 minus 3 times 4 is equal to, so that's 4 minus 12, that's equal to negative 8, and that's correct. So we are eliminating one of the variables. We're solving for the one that we didn't eliminate, then we check in the other. Sometimes it's not quite as straightforward as that example. Let's name them again. Now, if we add them this time, we're not going to get any further ahead. But what if we add twice the second one? What if we multiply maybe the second one by negative 1? Let's see what happens. Then we have by negative 2. Let's multiply by negative 2. Then we have negative 6x plus 2y equals negative 8. Now, if we put in there just 1, if we rewrite 1, then we have 4x minus 2y equals 2. Now, if we rename this 3, this is still 1. Now we can, that should be a 4. That's a 2. It's a funny 2. Now if we add them together, we're going to get rid of the y term. So negative 6x plus 4y is negative 2x. And negative 8 plus 2 is negative 6. So x is equal to 3. Then you're going to use x equals 3, put it in and find y. Then you'll check that your solution is correct. Another way of solving simultaneous equations is by a method that's just called substitution. Now, if we look at the first equation this time, then we can see that by rearranging the first one, we can see that x is equal to negative 13 plus 3y. Then if we use that in the second one, we reduce it to just being an equation in y. So we could write 4 times negative 13 plus 3y is equal to negative 24. And from there, we're going to get a value for y. Then we can find a value for x. Then we can check that it works in the first equation or the second equation. If we're looking at this as a geometric exercise, we can actually draw graphs of each of these. But the accuracy of your graph determines the accuracy of your answer. So let's draw y equals 3x minus 9. That's the first equation. That's 1 slightly rearranged. And then if I draw the second one, looks a bit like that. It's going to go through 4 and rearranging it. Now it's not going to go through negative 4, but I need to rearrange it so that if I rearrange it, it looks like that. So now it's going to go through negative 2 there. If I've drawn it accurately enough, I can read off that point of intersection there, and I can see on a beautiful graph that my answer there would be 2, negative 3. This graph's already drawn. We're looking at finding the intersection of y equals 4x and y equals negative 3x plus 7. If we've drawn it carefully, we can see that the point of intersection is 1, 4. So we're just reading off the graph where they meet. It doesn't have to be 2 straight lines. We can just read off the graph where they meet there. If you had an accurate graph, you could read them off. Similarly, we could find with a cubic and a straight line, we could find their intersection. We could read them off the graph if we had an accurate enough graph, and you can see there the answers have been given. That x is negative 1.27, x is negative negative 0.26, and at about 1.5.